This video is the alternate examples for number 2, talking about fractions. It was not on the original video that you watched just a little bit ago. So what we're going to do is we're going to find f of g of 2. So what that means is you're going to do f times g, and then what you're going to do is x is going to get replaced with 2. So what you're going to do is you're going to take the f function, which is x plus 2 over x minus 2, and then you're going to multiply that by x plus 4 over x minus 5. So what you're going to do is you're going to take the 2 and you're going to substitute it in. So when you substitute that in, that becomes 2 plus 2 over 2 minus 2 times 2 plus 4 over 2 minus 5. What happens is you're going to get 4 over 0 times 6 over negative 3. But what happens is, can you divide by 0? No. So this right here is going to end up being undefined. Why? Because you can never divide by 0. What happens is the domain for f of x cannot include 2. So when you plug 2 into x, it doesn't work. So that means that x is not part of the domain. Since x is not part of the domain, it's undefined. Okay? The next one is f minus g. So what we're going to do is we're going to take the f function, x plus 2 over x minus 2, and we're going to subtract g, which is x plus 4 over x minus 5. Now, in order to do subtraction of functions, there are 3 rules with fractions. When you multiply straight across and reduce. When you divide, you multiply by the reciprocal, and when you add and subtract, you have to get common denominators. So what you have to do is you have to figure out what your new denominator looks like. The easiest way to do that is first to factor if the denominators are factorable, which these are not. And then what you do is you just take and multiply your denominators together, x minus 2 and x minus 5. That means my new denominator is going to be x minus 2 times x minus 5. X minus 5. Okay. So x minus 2 and x minus 5 is my new denominator. So then what I do is I rewrite my new denominator. So I rewrite my 2 fractions with my new denominator like I did here. And then what I do is I go back to the top. How do I make this first fraction have a denominator of x minus 2 and x minus 5? What I have to do is I have to multiply this by x minus 5, which means I also have to multiply the top by x minus 5. Then what I do is I go ahead and distribute that. X times x is x squared. X times 2 is 2x. Negative 5 times x is negative 5x, which becomes negative 3x. And then negative 5 times 2 is negative 10. And so then I go ahead and distribute the numerators together. Leave the denominators separate, and that will help later on whenever we want to reduce, if we can. So don't multiply your denominators out unless it's absolutely necessary. So then what do I do to this right-hand fraction? What am I missing? This new denominator is x minus 2, x minus 5. We have x minus 5. We need an x minus 2, so we multiply by x minus 2. And then we distribute. X times x is x squared. X times negative 2 is negative 2x. 4 times x is positive 4x, which gives me a positive 2x. And then 4 times negative 2 would be negative 8. Then what you're going to do in the last step, okay, is you're going to combine like terms. Now, what happens is this negative sign right here impacts all 3 of these terms right here. So you're going to have x squared minus x squared, which is 0. You're going to have negative 3x minus 2, which is going to be negative 5x. You're going to have negative 10 minus negative 8, which is a double negative, which makes it a positive. So it's really negative 10 plus 8, which would be negative 2, over your denominator of x minus 2 and x minus 5. Then what you do is you try to reduce. In order to reduce, you have to reduce the entire numerator with the factors of the denominator, which does not reduce. So this right here would be your new function f minus g of x. Okay, so let's go over here and do f times g of x. So we do x plus 2 over x minus 2 times x plus 4 over x minus 5. So here's what you do on this one. Is multiplication is the easiest. You just multiply straight across. X plus 2 times x plus 4 over x minus 2 and x minus 5. Okay? multiply straight across. Then the only other thing you would maybe want to do is multiply your numerators together, and you're going to get x squared plus 6x plus 8 when you do your distribution. And again, only multiply your denominators together if it's absolutely necessary. In this case, I'm just going to leave them factored out. I'm good with this answer. I'm actually technically okay with this answer as well. I would accept either one of these on an assessment. I would accept the left one or the right one. Why the left one? Because right here it's really easy to tell if this does not reduce. There's nothing in the numerator and denominator that are the exact same. We can't get rid of it. Same here. In order to reduce this, you would have to factor it, which would take you right back to there. I would accept either one of those on the actual assessment. Okay. C down here, we have g divided by f. G is x plus 4 divided by x minus 5. All of that divided by f, which is x plus 2 divided by x minus 2. Notice when I did this, I made a big fraction bar to separate the original function g and the original function f, so we know what we're dividing. We're taking g, which is the top fraction, divided by f, which is the bottom fraction. Now, how do you divide fractions? You multiply by the reciprocal. So what I do is, instead of having to rewrite this, what I do is I call it the bracket technique. I take the bottom and the top and I bracket them. I take the middle ones and I bracket them. So what do you do with them? You multiply by the reciprocal. The brackets are essentially doing the reciprocal without having to multiply it. You take this top number, x plus 4. X plus 4, it gets multiplied by the bottom part of the fraction, x minus 2, and this part, the big fraction, goes on top. This x plus 4 is in the numerator, it stays on the top. X plus 4 is on the top, x minus 2 joins it. Then what you do is you multiply the two middle ones, x minus 5. The top fraction will tell you where the numbers go. X minus 5 is in the bottom originally, it goes on the bottom with the x plus 2. And this right here, I would accept that. The other thing you could do if you wanted to is multiply it out, and you could get x squared plus 2x minus 8 over x minus 5 and x plus 2. That would be something else that you could possibly do. I would accept either one of those two choices. Okay. Now I'm going to do E down below. Okay, so I have room. E is f plus k of x. So I'm going to do E, which is, let me go up here and bring it down here so I can see it, show you guys. Okay. So E, whoops, erase that here and grab it and drag it so you guys can see it. So I'm going to take E and move it down here. So here's E. Okay. E is f plus k. F is the function x plus 4 over x minus 5 plus the function of k. K we haven't used yet, so I don't know it. 1 over 2x minus x. So it'd be 1 over 2x minus x. So what you have is you now have three fractions. What I'm going to do is I'm going to make this second part a fraction. And I need to find out, in order to add and subtract fractions, I have to get common denominators. What you do is you factor your denominators first, none of these factor, and then literally all you do is you take the pieces and you multiply them together. 1 times anything is just itself, and then you make 3 new fractions with that common denominator. Minus 3 new fractions with that common denominator. Okay, so then what you do is you come up to the top and you ask yourself, how do I make this denominator of x minus 5 look like 2x? I need to multiply it by 2x. That means I need to multiply the top by 2x. Then what I do is I distribute that. 2x times x is 2x squared. 2x times 4 is positive 8x. Okay? Now, what do I need to do to this middle fraction? I need to multiply it by x minus 5 on the top and the bottom, which means I distribute the 1 and I'm going to get x minus 5. Okay? What do I need to do to this last one? I need to multiply it by 2x and x minus 5, which means I need to multiply the top by 2x and x minus 5 because it's missing both of those. And then you distribute. X times 2x would be 2x squared. So when I distribute these two together, I'm going to get 2x squared. Then I'm going to distribute that into this parenthesis here, which would be 2x cubed. minus 10x squared. And then all you do is you go through and you combine your like terms. 2x squared, are there any other x squareds? 2x squared, there's no other x squareds here. There's a negative. Remember, this negative has to impact both of these numbers, so it's 2x squared minus negative 10x squared, which would be a positive 12x squared. We have an 8x, we have an x, and we don't have any x's here, so that's going to be a positive 9x. We have a constant of negative 5, which would go at the bottom because that's the only constant. And then we have that 2x cubed. But remember that 2x cubed is really a negative sign because this negative right here has to impact it over x minus 5 and 2x. And that would be your new function.